Hi, my name is Jacob Morrison, and this is going to be a mini lesson on Oxy-Fuel combustion as a carbon reduction strategy. This is a deliverable presentation for Fuel Science 431 at Penn State University. So you may be asking yourself, what is Oxy-Fuel combustion? Well, it's actually a simplistic process that uses oxygen for combustion instead of conventional air. As you may know, air composition is typically made up of around 79% nitrogen and about 21% oxygen by volume. Without using that, we can use a lot less volume of gases for the combustion process. Also, using oxygen instead of pure air produces a flue gas comprised solely of carbon dioxide and water. This is why it's becoming a major technology of interest for CO2 capture. This is mainly due to, with the flue gas only being made of water and carbon dioxide, the water can be easily separated through condensation processes, and the carbon dioxide can easily be compressed for further transportation and storage. Another benefit without using air is there's very little NOx formation with very little presence of nitrogen within the combustion process. So to derive a oxy-fuel combustion system, there's three main components that must be added. The first is an air separation unit, which is typically a cryogenic distillation process, which means it first condenses the gas down into a liquid and then vaporizes off the different gases at various boiling points. The problem with this process is it's very energy extensive, which by using about approximately 200 to 200 kilowatts per ton of oxygen produced. Another component that is needed is flue gas recirculation. This is required to control the combustion temperature and ensure proper heat transfer. This is with the change in volume from using conventional air to oxygen. As the volumes decrease, the temperature will increase, so we need to pump back the excess flue gas to regulate that to keep with our previous design specs of boiler systems. This also further lowers the NOx emissions due to reburning of the flue gas. The last unit is a carbon dioxide capture and compressor unit, which is a multi-stage compressor to filter out other impurities that are introduced from air leakages within the system. It's a cooling process that first ensures that all the water is out of the flue gas and then condenses the final product down to 95 to 99% CO2 by volume. In this slide we can see a basic schematic of a boiler system design with the added components of the air separation unit, the flue gas recirculation, and the carbon dioxide condenser. As you can see, it does not take much more components added to make the system work, which is why it's a very economically efficient option and is easily adapted. So with this technology, there's many advantages and disadvantages. The first is we already have this technology. It's been around since about the 1980s to 1990s. Also, unlike other carbon capture methods, it requires no additional chemicals. Also, it can be easily adapted to all existing facilities since it just switches over the initial oxidant intake. It also has the option to do dual firing capability, which means it could switch from oxy-fuel combustion back to air-fuel combustion based on peak and low demands. Again, the flue gas, the volume is greatly reduced, which also helps later on by lowering the cost of having to process that. Unfortunately, the disadvantages are it is a high energy cost. Both the air separation unit and carbon capture both use about 200 to 300 kilowatt hours per ton that they filter, which really brings down the system efficiency. So lastly, we'll look at current use and future outlook. As of right now, it's still an initial proof of concept testing. There's 3 pilot plants as of right now across the country. There's the Callide A power station in Australia, the Schwarz pump power station in Germany, and Ciudad in Spain. The Schwarz pump power station is the most often looked at as its carbon capture rate has been 75 tons per day and has been operating as oxy-fuel for over 10,000 hours as of February 2015. The only concerns are for thermal and economic efficiency. The decrease in thermal efficiency is due to the additional cost, and project cost is proving to have a longer payback time than initially expected.